A lot of the formulas we're going to use this semester involve summing numbers. There's a convenient notation that we can use to express the sum of several numbers called summation notation. This video provides you with an introduction to summation notation. Suppose the number of runs scored in the last 4 games by a baseball team is 8, 4, 3, and 7. We want to know how many runs in total the team has scored over its past 4 games. Here's what we're going to do. Let's denote the run total from the first game by x1. x1 equals 8. The run total for game 2 by x2, so that x2 equals 4. Denote the run total from game 3 by x3. x3 is equal to 3. And denote the run total from game 4 as x4, so that x4 is equal to 7. The sum of the 4 run totals is given by this expression. This expression right here is called the summation notation. The summation is denoted by the capital Greek letter sigma. After the summation sign, we put x sub I. This means that x is our variable of interest, and the I in the subscript is the index that tells us we are going to start adding at x sub 1, and add up all of the numbers up to and including our final number, which is x sub 4. This entire expression means that we will sum x1, x2, x3, and x4. Since x1 equals 8, x2 equals 4, x3 equals 3, and x4 equals 7, this gives us 8 plus 4 plus 3 plus 7 for a grand total of 22 runs scored over the past 4 games. There are also a few equations that we'll use that force us to add the squares of numbers. Suppose that instead of wanting to know the total number of runs scored over the past 4 games, we want to know the sum of the squared number of runs scored over the past 4 games. We still have the same data. x1, x2, x3, and x4 still represent the same numbers, but our summation is going to look a little bit different. This expression here with the summation symbol out in front and xi squared following means that we'll take each number, square it, and then sum the squared values. So this particular notation means that we'll take x1 and square it, add on x2 squared, add on x3 squared, and then finally add on x4 squared. This gives us 8 squared plus 4 squared plus 3 squared plus 7 squared. The individual squares are 64, 16, 9, and 49. Adding these 4 squares together gives us a final total of 138. Note that the square of the summed values does not equal the sum of the squared values. For example, whenever we added up our 4 run totals earlier in this video, we got 22. 22 squared gives you 484. The second thing that we did in this video was we added up the squared values. We squared each individual value and then added the squares together. This gave us 138. So notice that the square of the sum values, 484, does not equal the sum of the squared values, which was 138.